Hello, and welcome back to this series on AP Computer Science on Educator.com. Today's topic is program design and development. These are some topics that are important considerations when you're designing and developing software. While you probably won't be asked to define any of these topics on your AP exam, you'll definitely want to keep these concepts in mind as you're considering answer choices on your multiple choice questions as well as your free response answers. And you want to make sure that your answers are consistent with solid software design and development principles, such as those we'll be covering in this lesson. We'll be talking about object-oriented programming, which is really at the heart of software development using Java. We'll then be going on to some additional topics, including top-down design and development. Be talking about reusable code, what that is and how that benefits us. We'll be talking about team development, what it means to develop software when more than one person is involved. We'll be defining and explaining the concepts of data structure and user interface, and then finally specifications. So let's get started. I'm sure you've heard the term object-oriented programming. It's kind of a buzzword that many people use even if they don't completely understand what it means. And so let's have a good definition here. Object-oriented programming, which is frequently abbreviated OOP, is a programming methodology based on designing the program as a world of interacting objects arranged in hierarchies of classes. So this means that we are modeling a real-world scenario in our software application, and we're identifying the objects in the real world that we're going to model in software. And we're creating those objects into classes, in hierarchies of classes that make sense in the real-world scenario that we're modeling. Two of the most important concepts in object-oriented programming are encapsulation and polymorphism. Encapsulation is the practice of making all instance variables private. And in a previous lesson I mentioned that on your AP free response questions, it is expected that you will make all instance variables private, and you will lose points if you make instance variables public. We also want to make all helper methods that are used only within the class private. And a helper method is a method that's defined within a class that's only used by other methods within that class. And it's defined to simplify the code in certain methods and also pull out code that's in common that may be called by multiple methods in our class. And if a helper method is only called by other methods within the class, and it's not designed or intended to be called by methods outside of the class, then we definitely want to make those methods private so they are not inadvertently used by other code external to our class. As a result of making these instance variables private and the helper methods private, the clients of a class, that means other code external to a class that calls methods in our class, interacts with the class only through the public constructors and the public methods. The constructors, public constructors and public methods are known as the interface to our class. They are how people or code external to our class interacts with our class. Now, this concept of encapsulation is also sometimes known as information hiding, and it means very much the same thing, that we don't expose the internal details of our class to anyone outside of the class. We allow them to interact with the class only through the public constructors and methods. The other one of the two most important concepts in object-oriented programming is polymorphism. We talked about this in a previous lesson, and polymorphism is the mechanism that ensures that the correct method is called for an object that is disguised as a more generic type. So we may have a class called person, and we may have a subclass of person called student. And there may be methods that are defined for student that are not defined for person, or that are redefined in student and override the definition of those methods in person. So even if we have a collection of person objects, such as a list or an array of person objects, if the person object really is a subclass, if it really is a student, we can call methods of the person object, and polymorphism is what makes sure that the definition of those methods in the student object, which is the more specific type, is called, even though the collection is a collection disguised as a more generic type, person.